All right, now we're going to be using the so-called triboelectric table to answer some questions, and those are questions 2 and 3 about what happens when you rub objects together. So one thing, when I publish your second practice test, or actually put it out and give it to you in class, I'm recording this Sunday, so that'll be tomorrow. I want to actually cover up this side here because I think it's more confusing than helpful. So I'm just going to do that right now, even for this problem. Basically, the rules for the triboelectric table base just tell us this, that the further down you go, or basically if you rub two objects together, the lower object takes the negative charge. That's really the rule for any of these triboelectric rubbing problems. So we'll keep it really simple. Here, we have a problem where we have a glass object and wool cloth rubbed together, and we want to know which statements are true. Well, first, since glass is here and wool is down here, this tells us that the wool cloth is going to be negatively charged and the glass object is going to be positively charged. And we know from the previous page that only electrons can move between charged objects or between objects when we're doing triboelectric charging, which just means charging by rubbing objects together. So with that in mind, let's be clear. First, if only electrons can move, we cannot gain or lose protons. That removes choice A as a possibility. Now, we already have decided by looking at the triboelectric table that the wool does become positively charged. Okay. One other rule I want to be clear on. You don't create charge. You scrape it off one object and give it to the other. So what that means for D is if we happen to acquire plus 5 units of charge on the glass, then the wool is going to actually give us, it's not going to give us, it's going to acquire negative 5. In other words, you remove, you basically transfer negative 5 units of charge onto the wool object, and that reveals a plus 5 on the positively charged glass. Now, statement E, in real life when something happens, you may never violate conservation of charge. And just to review, conservation of charge basically says you can never create or destroy charge. So charge is never, so net charge is never created or destroyed. All right. Now, electrons are transferred from glass to wool. That's true. But once again, we never transfer protons. Okay. Now, once they are charged, they should have opposite charges on each other, and therefore they should attract. And by the way, the word affinity, it's a good little ACT word that means liking. Okay, good little ACT, SAT word. So glass materials do not have a greater liking. They have the opposite. They have less of a liking. All right, and then number 3. Which statement best explains why a rubber rod becomes negatively charged when rubbed with rabbit fur? The best explanation, well, if we look at the triboelectric table, rubber is in fact lower than rabbit fur. Rabbit fur's up here, the rubber rod's down here, so it is going to be negative. And basically, it's negative because it likes the electrons better. So it's really just choice C. Don't overcomplicate it. It's not about insulators or conductors. It's simply the fact that molecules in the rubber rod have a stronger attraction for electrons than molecules in the fur. So that's questions 2 and 3, and we'll look at question 4 in the next video.